Okay, my dear students, we are going to start second part of cost control, chapter number 18, cost control. This is the second part, and in this we will discuss earned value method of cost control, inshallah. So allow me to say Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulullah. Rabbi shrah li sadri wa yassir li amri wahlul uqdatan min lisani yafqahu qawli. Assalamu alaikum wa rahmatullah to each one of you, to all my students and viewers and all those engineers who would like to watch this cost control video. So, as I said, we are going to discuss in this video that earned value method. Okay, the earned value. This approach of determining project progress addresses both schedule status, like whether we are on schedule or behind schedule, or we are ahead of schedule. We are building fast or slow. In terms of schedule, are we going fast or we are going slow? Okay. So similarly, cost status, are we on budget, are we over budget, we have spent more money and getting less, or we are under budget, like we are making more profit and our cost is less. The system is called the cost and schedule control system criteria, cost and schedule control system criteria. Okay. So we will go with the simple thing with the background. Performance review meetings can be powerful tool to help control project costs. Knowing you have to report on your progress is an incentive for people to perform better. So if like somebody is monitoring your progress or you have to report your progress, so this gives incentive to the people that they can perform better. Okay. So to control, we can have a review meeting as we have discussed in the previous part one. So this, as you know that in the last chapter 17 about estimating process, and that video was 2 hours almost. So now I have broken this video into two parts. So each lecture will be less than 1 hour, inshallah. Performance measurement is another important tool for cost control. There are many general accounting approaches for measuring cost performance, but earned value management method is a tool unique to construction management. Okay. So this is a very, every engineer in engineering, we use this tool for the cost control. Earned value method. So what is earned value method? Earned value method is a project performance measurement technique that integrates scope, time, and cost data. So we are in this we will integrate the scope of the project, time of the project, and cost of the project. Given a baseline like original plan plus approved changes. So baseline is always our original plan plus approved changes. So that will be, you can determine how well the project is meeting its goals. Okay, you must enter actual information periodically to use earned value management method was WBS, work breakdown structure item completed, or approximately how much of the work was completed. Actual start and end dates, okay. Actual costs. Organization around the world are using EVM to help control project cost. Okay, so this, these days every organization is almost using earned value management method to control the project cost. Okay. So now we learn these earned value management terms that we are going to use in this. So three terms, basic three terms we need to remember how we are going to evaluate these. First is planned value. Okay, we call it planned value or PV, formerly called budget cost of work schedule. Formerly called budget cost of work schedule, like based on our original bid price or contract. Okay. So this is our original contract. Actual cost, AC, actual cost AC, formerly called actual cost of work performed. Now we sign the contract based on our estimate, that is our PV, okay, budget cost of work schedule. Now, actual cost is we will be building the project based on we will be buying material from the market, we take equipment, we pay to the labor. So we are spending money and building the project based on the market prices. And that will be the actual cost that we are spending on building the project. Okay? So that will be our AC. And it's maybe more or less than the planned value. The planned value is our estimated bid price, estimated bid price that we have submitted, including our overheads and profit. Earned value is formally called the budgeted cost of work performed. Budgeted cost of work performed. So this is the earned value. So this will be like the value that we are based on the work done. We will be claiming money or getting the payment from the owner based on the work done. How much percentage of work is complete? So according to that percentage of the work on site that is complete, we will apply for payment, and that will be payment will be approved by the consultant and the owner. So this is monthly progress payments we will be receiving based on the work done. Okay. So now again a little bit more in detail. PV or planned value, budgeted cost of work schedule. The planned value, formerly called the budgeted cost of work schedule, is also called the budget. Okay, this will be our budget, like the original contract, based on our estimate that we have signed the contract, that we have submitted the bid. So that contract that we have signed between the contractor and the owner, so that gives us the PV or planned value. So it's a BCWS, budgeted cost of work scheduled. Now actual cost, AC, formerly called the actual cost of work performed, is the total of direct and indirect costs incurred in accomplishing work on an activity during a given period. Costs incurred to accomplish the work that has been done to date. Okay. Say, for example, we have Saudi Riyal 20,000 to accomplish a task over 2 weeks. It means we may spend Saudi Riyal 15 in week number 1 and Saudi Riyal 5,000 in week number 2. Okay. So total cost is 20,000. So this is like we build the project based on buying material from the market. We pay labor, we pay equipment, we pay to our engineers overheads. So this is like actual cost that we are spending on building the project based on the market prices. Earned value, EV, earned value is EV, formerly called the budgeted cost of work performed, is an estimate of the value of the physical work actually completed and claimed for from the owner for payment. The EV is based on the original planned cost for the project or activity and the rate at which the team is completing the work on the project or activity to date. The planned, not the actual cost to complete the work that has been done to get payment. Okay. So earned value will be like the work we have completed. So work we have completed in terms of percentage, how much work is complete, like 10%, 20%, 30% work is complete. So that we can claim that in this month we have done this much work. So we submit the payment and that will be approved by the consultant and the owner will pay the money to the contractor. Okay, so this that will be our earned value based on the work done. Okay, based on the work done, but the payment we will be getting based on the original contract that we have signed with the owner. Okay. So it is not like based on the actual price. So earned value, we will be claiming the payments based on the work done, but according to the signed contract. So how much percentage of work is complete, we will submit the payment accordingly for each month progress payments. Now, earned value or budgeted cost of work performed. So here they have given two things. Like one is budgeted cost of work tool is PV, pink is PV, and budgeted cost of work performed is EV. Okay, budgeted cost of work performed is EV. In this graph, two values are shown. Okay, EV and EV. Okay. So on the x-axis we have time, on the y-axis we have the amount. Now in this example, we are going to drive this how much is value of PV, EV and AC. So there are four activities A, B, C and D, and these we have planned like we want to complete on Sunday, Monday, Tuesday, Wednesday and Thursday. Okay. So 5 days. These activities are spread over 5 days. Like activity A is for Sunday, and planning is this activity cost is 50. Activity B is spread over 2 days, Sunday and Monday. So then its cost is Saudi Riyal 100. Okay. So activity C is for 2 days, Monday and Tuesday. Its cost is Saudi Riyal 200. And activity D is for 2 days, Wednesday and Thursday. So its cost is 100 Riyal. Okay. So this is our PV. Now we have to find the status of the project after working 2 days. Okay, so we have like this project is 1, 2, 3, 4, 5 days a project. So after 2 days, what is the status of the project? Okay, that we are going to determine. Okay, so how much will be the PV value, AC value, and EV value for after 2 days of work, Sunday and Monday. Okay, so PV is budgeted cost of work schedule. So see, and when we are at we have finished time 2 days, so it means work A is planned is 50 is complete. So then work B is also complete for 100 Riyal. Work C is 200 Riyal for Monday it will be 100 Riyal, and for Tuesday will be 100 Riyal. So for this until 2 days from work C, we are going to complete 100 Riyal. So this PV value at this point will become 250. You know, when we add budget cost of work schedule PV, 50 plus 100 plus 100, so it's a 250. This is our PV. Okay. Now what they say is work A is to find EV. Work A is 100% complete, but work B is 80% complete, and work C is just 20% complete, and work D is not yet started. Okay, so with this data, we can calculate the EV, budget cost of work schedule. So its first work is 50, so the real 50 multiplied by 100%. Okay, because this work is complete. We are going to check the status at this arrow after 2 days. So plus, for work B is price is 100, but this work is 80% complete. So we can claim payment for 80% of the work done. Okay, so 100 multiplied by 80% plus, then work C is just 20% complete. Okay, so total price is 200. So among the 200, just 20% is complete. So this is by this way we calculate this value. Earned value is 170. Earned value is 170. Now to calculate actual cost based on the market prices that we are going to build this project. So what they say is activity A, we have spent 60 Riyal. Okay, so we got 60. For activity B, until now we have spent 110 Riyal. For activity C, we have spent only 30 Riyal until now. Okay, after 2 days of work. So where we have to find the status. Now is mean AC is for AC in how much we spend in the market price is 60 plus then for activity we have spent 110. For activity C we have just spent only 30 Riyal. Okay, to complete of the work, only 30 they are. So our AC is 200. So this is the way that we can calculate how much is the PV planned value, how much is the earned value, and how much is the actual value or budget cost of so planned value or our budgeted cost of work schedule PV. PV is the budgeted cost of work schedule. EV is budgeted cost of work performed, and AC is actual cost of work performed. Actual cost of work performed. So we have final three values. Okay. Now, with this understanding of PV, EV, and AC, we are going to drive these, some matrix. We have actual value for PV, EV, and AC. Okay, we have actual value for PV, EV, and AC. So now we are how do we apply them? Okay, so it means we SV is a schedule variance. Schedule variance is EV minus PV. EV minus PV, or EV means budgeted cost of work performed, minus PV means budgeted cost of work stored. A comparison of the amount of work performed during a given period of time to what was scheduled to be performed. A negative variance means the project is behind schedule. So if this either we can remember either way, we can remember either way. So it's a negative value like EV minus PV, okay, or BCWP, budgeted cost of work performed, minus BCWS, budgeted cost of work scheduled. Okay. So EV minus PV, if this value is negative, variance means that we are behind schedule. Meaning is EV is planned value, EV is earned value. So it means we are getting less. EV is less and PV is more. Okay. Planned value is more and we earned value is less. So we receive less money from the owner and we spend more. Okay, negative value means that we are behind schedule. Okay, this is schedule variance. So cost variance is EV minus AC. Cost variance is CV is cost variance is EV minus AC, or EV is budgeted cost of work performed minus actual cost of work performed. Actual cost of work performed. A combination of the budgeted cost of work performed with the actual cost. Okay. A negative variance means the project is over budget. Okay. Negative variance means in cost variance that our actual cost is more and we have received less from the owner in terms of EV. So then a negative value means project is over budget. Okay. So it means we are not making profit in this project and we are over budget and cost is high. Cost is high. So with this, we some more derived metrics like schedule performance index (SPI). Schedule performance index is EV over PC. Okay, if SPI schedule performance index is less than one means that EV will be less and PV will be more. So project is behind schedule. Then CPI, cost performance index, CPI is equal to EV over AC. So it means if this value is less, it means AC is more, EV is less. So actual cost is more, EV is less. So cost performance index CPI is less than one means the project is over budget. Project is over budget. So CSI, cost schedule index, CSI cost schedule index is equal to multiplication of CPI cost performance index multiplied by schedule performance index. Okay. So if these both values are less than one, so it means when we multiply these both, the value will be more less. Okay. The further CSA is from less than one, the less likely project recovery is possible. Okay. So it means and their project recovery will not be possible. Now what we have learned is these values So every time, it's very easy to remember these formula because these is always schedule variance is EV minus PV. Okay, cost variance is EV minus AC. Okay, schedule performance index is EV over PV. Okay, cost performance index is EV over AC. EV over AC. So every time we have EV minus PV or EV minus AC. So for schedule, EV minus PV. For cost, it's EV minus AC. Similarly, schedule performance index is EV over PV, and cost performance index is EV over AC. Okay. If these values are positive, okay, so like the first two values are positive, so it means positive we will be like EV is more and PV is less, so it means that we will be ahead of schedule. Okay, so negative value means we are behind schedule. Positive value means we are building fast and we shall be ahead of schedule. And similarly, if this cost variance is positive, so it means its project is under budget. Cost is low, that means so if this value is negative, it means the project is over budget, and cost is high. So it means if in case of negative, it means we are over budget. We are spending more. AC value is more and EV is less. So then we get the negative value. So we are spending on market basis much more than what we are getting from the owner based on the work done. So we will be making loss. Similarly, other two values like this first two value is positive, that's good. Similarly, SPI EV over PV. So it means if this is greater than 1, it means EV will be more, PV will be less. Okay, so we will get greater than 1 answer. Similarly, CPI is EV over AC. So EV value is more and AC is less, and then we will get value more than 1. Okay. So with this, if this happens, this is good. This is good that we shall be ahead of schedule and we shall be under budget. Our cost will be low. So based on this information, we apply these things on these graphs, and here we can see that we have three graphs. One is budgeted cost of work performed. Budgeted cost of work performed. This means EV, and budgeted cost of work sold is PV, and actual cost of work performed is AC. Okay. So now EV is more EV minus PV, EV minus PV, EV is more, so we get the positive value. So it means we are ahead of schedule. And when we say ahead of schedule, it means we are building fast. Okay, in terms of schedule, we are fast. Then in terms of cost, EV is more than EV minus AC. So EV minus AC, EV is more, EV value is more, AC is less. So it means this value is also positive. So it means we are under budget. So project cost is low and we are making profit. Okay. This figure shows this one. So let's see what the next figure shows is. So if in terms of schedule, we will say fast or slow. Okay, fast or slow. If it's fast, we will be ahead of schedule. If it's slow, we will be behind schedule. Okay. So negative value will become behind schedule. And then similarly, cost is, we will say cost is low or high. So if the cost is positive, so it means under budget, and then cost is low and we will be making profit. If cost is negative, so it will be high, then we will be like over budget. We will be spending more and getting less. Okay. So for this, this figure, you know, for this figure, ACWP is at the top, AC is at the top, and BCWP EV is in the middle, and BCWS is PV is at the lowest. Okay. So when we make EV minus PV, so we get this answer is positive because this the EV is more and PV is less. So we get positive answer. We are ahead of schedule. Ahead of schedule, so it means we are building fast. Okay. Now in terms of EV minus AC, so AC value is more and in EV value is less. We got negative answer. Negative answer. We are over budget. Over budget means we are spending, more. Cost is high, and we will be making loss. So let's apply the same concept to the next diagram. Next diagram. In this diagram is like we have BCWS at the top is budgeted cost of work stood as PV, and budgeted cost of work performed is EV. Budgeted cost of work performed is EV, and actual cost of work performed is AC. Okay. So now when we calculate EV minus PV, EV minus EV, because EV is less and PV is more. EV is at the top. So we get negative answer. Negative answer means we are behind schedule. Behind schedule, it means we are building slow. No, we are going slow in terms of building the project. Then we come to the EV minus AC. Okay, so EV minus AC, EV is more and AC is less. Okay, so budgeted cost of work performed is more and budgeted cost of actual cost of work performed is less. So in this case, we got a positive answer because EV value is more. So we are under budget. When we say under budget, it means we are cost is low. Okay, so in terms of cost, we categorize low or high. Okay, in terms of schedule is fast or slow. Okay? Fast or slow. So go to the next slide. What it says that if these three graphs are given, like budgeted cost of work scheduled. Okay, PV is at the top, and then actual cost of work performed is in the middle, and budgeted cost of work performed EV is at the bottom. Okay, so it means when EV minus PV, we got because EV value is less and PV value is more, so we got negative answer. So it means we are behind schedule. Behind schedule, it means we are building going slow to build the project. Similarly, when we have EV minus AC, so AC is more and EV is less, but the cost of work performed is less, actual cost of work performed is more. So answer is negative, and when answer is negative, we are over budget, and over budget means that the cost of the project is high, and we are making loss. Loss. We are not taking profit in this situation. Okay. So to comment further, we are going to solve now one example that we solve this question in the class, like classwork. So we have here, the graph is given, and there is a budgeted cost of work tool. So at the top is written in the legend is PV, and PV is 55,000, and then budgeted cost of work performed. Budgeted cost of work performed is EV. EV is pink color, so it's 49,000. And AC is actual cost of work performed. Actual cost of work performed, red color. Actual cost of work performed is value is 56,000. Okay, 56,000 is the AC. Okay. Now we know these formulas that always SV schedule variance is EV minus PV. Cost variance is EV minus AC. Okay. So SPI schedule performance index is EV over PV, and cost performance index is EV over AC. Okay. So now we know these PV and EV and AC three values we know from this graph. So then we find out the schedule performance in the next slide. Schedule performance. Schedule performance is SV is EV minus PV. So we got a negative answer of minus 6,000. Okay, negative answer of minus 6,000. So it means we are behind schedule. Okay? So what they said that we have accomplished 6,000 worth of output less. Okay, so we are behind schedule means so our output is 6,000 minus 6,000 is less than we should have achieved. Yeah, similarly, cost variance is CV is EV over minus EC, EV minus AC. So EV is 49,000, AC is 56,000. So we got a negative answer of 7,000. So this is we are over budget. Okay, negative answer means we are over budget. We are over budget. So cost is high. So we are not making a profit in this project. Okay. So then we calculate SPI. SPI is EV over PV. So EV is 49,000, PV is 55,000. So we got answer is 0.891 or 89.1%. So it means that this value should be more than 1, but this value is less than 1. So okay, we are performing at 89% of where we should have been on the performance. Okay. So it's we are looking for that SPI should be greater than 1. Okay, but in this case, it's not greater than 1. It's 0.81, 0.891. Okay. So now it's CPI. We calculate schedule performance index. Now we calculate cost performance index is EV over AC. EV is 49,000. AC is 56,000. So the value is 0.875. So percentage it's 87.5%. So we were looking this also more than 1, but it's less than 1. So it means we are we are cost is over budget. Okay, cost is over budget. Our cost performance is little worse than the schedule performance index, and our efficiency rate is 87.5%. So our rate should have been more than 100%. It should be more than 100%. Should be greater than 1. When we multiply this both CSI then is CSI is SPI multiplied by CPI. Okay, multiply by CPI. So then both, because both values are in points, so then our value drops more. Okay, from 89.1% to then CPI was 87.5%. Now we got CSI is cost schedule index is 0.891 multiplied by 0.875 is equal to 0.78 or 78%. So this means value has dropped more. Look at the impact when we combine the two. So less likely recovery of this project is possible, because we are behind schedule in terms of we are over budget. So then here when we apply this like in the graph earned value is how we draw the curve. Earned value, budgeted cost of work performed, budgeted cost of work from BCWP, and actual cost of work performed AC. Actual cost of work performed plotted against the baseline like PV. Budgeted cost of work schedule, budgeted cost BCWS. So when we plot this, so we got the value of is our PV is here. PV budget cost of work performed is our EV. EV is this one. Budget cost of work performed is 49,000 here. So then our P value is here. That is until this point we got 55,000, and then our value for actual cost of work performed. Okay, actual cost of work performed value is here. So then difference of this EV minus AC. Okay, EV minus AC is cost variance is equal to cost variance, and we got the negative value. So we are over budget. Similarly, our PV is here 55,000 and our EV is 49,000. So again, SV is EV minus PV. We got the negative value, so it means we are behind schedule. Okay, so our EV is less and PV is more, so we are behind schedule in terms of schedule. So with this, we move forward. So now from this point we are going to present another example. So those who students who could not understand before, so they should pay attention. And from this, it will be like again we are going to learn earned value method first time. So concept of earned value. A concept of earned value analysis. Concept of earned value is simple. At any given point, find out how much work you have done, and how much you plan to do by this date. Okay. So earned value analysis is how much money you have earned and how much money you have spent. Okay. How much money you have earned like EV and how much money you have spent based on the market prices to build the project. Okay, calculate time like schedule variance and money budget deviations. Okay, so analyze cases for major deviation and suggest remedies. Okay, conclude these deviations to the end of the entire project. Conclude these deviations if we build with the same pace. So what will happen to the end of the project? So these kind of things we are going to find out in this one. Let's take the example number 2. It's very simple example to make earned value analysis. Let's assume an owner contracted with the mason to install 10,000 concrete masonry units at a price of $4 each in a total time of 20 days. Time of 20 days. Now, after 5 days, just after 5 days, the mason reported that 2,800 blocks has been installed. After 5 days, he installed 2,800 blocks. His cost so far, including overhead and profit, was so he spent until after 5 days, he spent $11,900. So what is the status of the project? This we have to tell from this data. What is the status of the project? So what is the status of the project? Like we have to fill this table, answer all these questions. Like what is activity was concrete masonry unit? What is total budget? What is how much percentage of the project is complete, and how much is actual cost? Actual cost of work performed, the budgeted cost of work for how much EV value, and how much budgeted cost of work scheduled, like how much is PV value, and how much is the cost variance, how much is schedule variance, how much is schedule variance in terms of number of days. Okay, and how much is the cost performance index and schedule performance index and future cost variance and future schedule variance. Okay, so these values we have to find out from this given data. Now let's move to the solution of this example. Total budget is 10,000 masonry, concrete masonry units. So each unit is cost $4. Each unit costs $4. So total budget of the project is $40,000. Okay. Then is the total duration of the project is given to us 20 days. So concrete masonry unit per day, how many, if we divide it by 20, so it means each day we should install 500 concrete masonry units. So in 5 days, we should have installed 500 multiplied by 5, so 2,500 concrete masonry units. But actually, he has installed more than 2,800. So concrete masonry unit installed in 5 days, it's given 2,800. Okay. So it means he is building fast here from this. And daily planned budget, so 40,000 total budget. If we divide it by 20, so it means we should spend it $2,000 each day for 20 days to consume the total budget of 40,000. So percent complete, how we will calculate the percent complete is we have installed 2,800 blocks and total blocks are 10,000. So we divided by 10,000. So it means 28% of the project is complete. 28% of the project is complete. Now we define those values, definitions, like what is AC and what is EV and what is PV. Okay, let's see what is AC is. Actual cost of work performed, ACWP, actual cost of work performed. This is what it actually cost the mason so far. So it means based on the market price, how much money he has spent until now for working for 5 days. Okay, actual cost called actual cost AC. Okay, budgeted cost of work performed. Budgeted cost of work performed is EV. This is what the mason will get paid for work performed so far. So how much percentage of work is complete? So we can get payment according to that. And this value we call it earned value EV. Budgeted cost of work scheduled BCWS is our PV. This is what it would have cost the mission so far if the work on schedule and on budget. If the work is according to schedule, so this is our planned value. Actually, planned value, also called the planned value. Note that all numbers here should include overhead and profit. Okay, so all numbers here, they are going to include overhead and profit for the bid price. So now we calculate these values. What is how much is AC? AC is given to us actual cost of work on up to 5 days. He spent 11,900. Okay. So EV is a budgeted cost of work performed. Budgeted cost of work performed. So it means how much is we have two ways we can calculate. One is we have he has installed 2,800 blocks and in each block is a $4 so the earned value is 11,200. Then or earned value we can calculate by in terms of how much percentage of work is complete. 28%. This we have calculated before. We multiply 28% with the total value 40,000. So the EV is 11,200. Similarly, PV is budgeted cost of work schedule, so it's $2,000 per day multiplied by 5 days. So it multiplied by 5 days. So we should have like PV is $10,000, $10,000, or we can calculate is 40,000 is the total budget. So for 5 days divided by 20, so we will spend we will spend. We will spend 10,000. Okay, so where does the mason stand now? So it means we have to calculate now schedule variance, cost variance, cost performance index, and schedule performance index. Okay, we know we are going to calculate this CV cost variance is EV minus AC. Okay, budgeted cost of work performed minus actual cost of work performed. So when we put this value 11,200 minus 11,900, so it's minus 700, minus 700. So it means that EV is less and AC is more. So we are getting less and we are spending more. So we are over budget. The negative value indicate we are over budget. So similarly, schedule variance is EV minus PV. Okay, budgeted cost of work performed minus budgeted cost of work scheduled. Okay, so 11,200 minus 10,000. We have calculated EV before. EV is 11,200 minus PV is 10,000. So we got positive 1,200. So this when schedule variance is positive, so it means we are building fast and we are ahead of schedule. So similarly, we can find schedule variance in number of days. So schedule variance, we know that we have to divide it by daily planned budget. Okay, so it's this value is 1,200 divided by $2,000 per day. Daily planned budget is 2,000 per day. So it means how much we are ahead of schedule is until now after 5 days is 0.6 days ahead of schedule. Then cost performance index is EV over AC. Cost performance index is EV over AC or budgeted cost of work performed over divided by actual cost of work performed. Okay. So by this way is EV is 11,200 divided by Actual cost 11,900. So this value is less than 1, is 0.94. So this indicates that we are over budget. We are spending more and getting less. So schedule performance index is EV over PV, or budgeted cost of work performed divided by budgeted cost of work scheduled. Okay. So EV is 11,200 divided by 10,000 is 1.12. Okay, 1.12. So this is positive, like more than 1, and this indicates that we are ahead of schedule. Okay, ahead of schedule. So to find the other values, now CV, see we have find out EV and AC and PV, and then we found out CV and SV, SV in days, CPI and SPI. We have find out all these values. And now CV and SV are absolute parameter for measuring deviations from the baseline budget and schedule. Okay, CV and SV. Then CPI and SPI are relative measures like percentages. Always strive for, like CV, cost variance and schedule variance should be greater than or equal to 0. Okay. Should be greater than 0. Then CPI and SPI should be greater than 1. Okay, should be greater than 1. So it means we are looking for that CV and SV should be positive. Okay, and similarly CPI and SPI should be greater than 1. This is what we are targeting. EV is also used to forecast future deviations. EV is also used to forecast future deviations. So what is the future cost variance is cost variance divided by percentage complete. Okay, remember this how we have to equate future cost variance. So cost variance divided by percent complete of the project. So CV we have calculated before is minus 700 divided by percent complete is 28% of the project. So this value is minus 2,500. Okay, future cost variance. It means if we continue with this same pace, so we will have total loss of $2,500. Future schedule variance, SV over percent complete. So SV we have calculated before is 0.6 days ahead of schedule, and we divide it with the percentage complete 0.28. So it means so total number of days becomes 2.14. It means future schedule variance. We will complete this project 2.14 days ahead of schedule. Okay. Similarly, interpretation is given below. Interpretation for future cost variance and future schedule variance. If the project continue with the same pace, the contractor will finish the project 2.14 days ahead of schedule and with the budget deficit of 2,500. So it means we will be making loss of 2,500 because this value is in future cost variance is negative. Okay. Now we have find out all the values. So we fill the table. Total budget is 40,000. Percent complete is 28%. AC value is 11,900. EV value is 11,200. PV value is 10,000. CV value is minus 700. Schedule variance is 1,200. And SV in days is 0.6 after 5 days. CPI is 0.94, SPA is 1.12, and future cost variance is 2,500. So future schedule variance is 2.14 days. So what this indicate to us that project is 28% complete. Project is ahead of schedule by 0.6 days. So plan to finish a 2,500 concrete masonry unit, but he has installed 2,800 masonry units. Project is over budget. Project is over budget because minus 700 cost variance is minus 700. Project is over budget. So earned value we have 11,200, but we have spent 11,900. So we have made a loss of minus $700 until now after working of 5 days. If the project continue with same pace, the contractor will finish the project 2.14 days early. Okay, 2.14 days ahead of schedule, but with the total budget deficit of 2,500. So total loss we will face as 2,500. Okay, future cost variance is minus 2,500. So with this, we have find out the values. Now we see that where are you now? Okay, where are you now? So we have these four quadrants. Quadrant number 1, 2, 3, and 4. Okay. So on x-axis is the time. On y-axis is the dollar amount. Okay. So now in quadrant number 1, time is positive and dollar amount is positive. In quadrant number 2, time is negative, but dollar amount is positive. Similarly, in quadrant 3, so both time is negative and dollar amount is negative. In quadrant number 4, time is positive and cost is negative. Okay. So where our project lies now, according to the data, quadrant number 1, ahead of schedule. So what it shows, because both values are positive, so it means ahead of schedule and under budget. Okay. Quadrant number 2 is in terms of time, it's behind schedule, but in terms of cost is under budget. Okay. So we are making profit. Okay. For quadrant number 3 is we are behind schedule, time is negative, behind schedule, and cost is also high, so we are over budget. So quadrant number 4 is because the cost is negative, so it's over budget, and in terms of time is positive, ahead of schedule, or we are building fast. So then, but we are over budget. Okay, cost is we are spending more and getting less, so cost is negative. Okay. And over budget, so we are cost is high. So with this, we have finished this how to find out values with the earned value method. So in whatever in example number 2 was asked to us that we have find out that the project is 28% complete and it is ahead of schedule. 0.6 days after working of 5 days, and we can complete as 2.14 days early, but with the budget deficit of 2,500. So this we thank you very much for your attention. Inshallah, next time we will discuss another chapter about this course. So today we have discussed this method is earned value management method or to control the cost of the project. To control the cost of the project, earned value method EVM. Okay. So important is that you should make understanding to find out how to find PV, EV, and AC. Once you know this one, the rest of the things is simple, you know. So to remember these formulas is always schedule variances EV minus PV, cost variances EV minus AC, schedule performance index is EV over AC, and cost performance index is EV over AC. So it's always EV is first and then the second, you know. So when we do schedule variance, we compare EV and PV. Okay. When we do cost variance, we compare EV and AC. Okay. Similarly, schedule performance index is EV over PV and cost is EV over AC. Okay. So with this, cost, we calculate either under budget or over budget. Our cost is low or high. Okay, and in terms of schedule, we say ahead of schedule or behind schedule. Okay? So it means ahead of schedule means we are building fast, and behind schedule is we are building slow. Okay? We are building slow. So with this, we have finished chapter 18 about cost control, and we covered in the both lectures a number of methods how to control the cost or how to apply the earned value method. Okay, so with this, I would like to say Subhanakallahumma wa bihamdika nashhadu an la ilaha illa anta nastaghfiruka wa natubu ilayk. So thank you all for your kind attention. Inshallah, see you next time. Assalamu alaikum wa rahmatullahi wa barakatuh.